So as we are saying, sorry for the echoing delay. So as we were saying, we'll be solving that equation. So let's deal with that equation using the chain rule and the product rule as well. We have the equation over here. Let's say just the equation was itself x squared times root over of 4x plus 6 divided by 3, isn't it? Let's forget this part at first. Let's consider our fx as, let's say, root over 4x plus 6 whole cube. Okay, let's consider this as at first. So that means we have g of x as what? This whole, which is 4x plus 6, writing that root over as power of half and multiply it with 3. Sorry, multiply with 3. We get what? Or like that's how we represent that root, isn't it? This is the power of root, representing the power of root, like the root as the power, and that power 3 is going to get multiplied with that another power. Like they are going to simply get multiplied. So if you find it difficult, we can also, like for simplicity, we can write it in this way. This is how we deal with it. 4x plus 6. So they are going to get multiplied and 3 by 2. Okay, now this is gx. And h of x, note take here that h of x is another function, which is the inner function 4x plus 6. Okay, we can write it with some other portion, other ink, 4x plus 6. Okay. Now, initially, we need to find what? F prime of x means, according to the chain rule, g prime of like whatever is inside, like over here, this hx, I mean, this x represents what? This represents a function, h of x, isn't it? So g prime of hx multiply with itself, like h of x, isn't it? So doing so, at first, let's find the g prime of x. G prime of x is just differentiate the outer part, like whatever is inside we don't care, whatever is outside, the power, like the power is included on whichever part, we are going to just consider that. So this power is what? 3 by 2. So consider this inside as what? A. So a to the power 3 by 2. So differentiating this a to the power 3 by 2, this is what? Let's say like we have a function u equals to a to the power 3 by 2. Okay, then we are going to differentiate du over dA. Okay, that means with respect to a, we are differentiating. We are going to consider this, like the term, like we are going to differentiate that term with respect to that term, whichever we are writing at the like bottom. Like here we used to like differentiate with respect to x. That's why we used to write dx, like dy by dx, isn't it? That means we are differentiating with respect to x. In this case, we're like differentiating with respect to a. That means we're just going to consider the powers of a only. Even if there was a constant at the front, we wouldn't have considered. Or if we have, let's say, b here, we would have simply considered that b as a constant value. But whatever is given at the bottom, at the denominator of this expression du by dx or dy by dx, or the differentiation expression, at the bottom, whatever it is at the denominator, we are going to simply differentiate the whole term with respect to that term, that simple like term. In this way, in this case, it is a. So differentiating with respect to a gives us what? 3 by 2 times a to the power 3 by 2 minus 1. That's the formula. So implementing that gap, that gives us 3 over 2 times, simplifying this gives us what? 3 by 2, and 2 ones are 2, so minus 2 here. So 3 minus 2 is what? 1 over 2. So that means this gives us a value of a to the power 1 by 2. So this is our expression, isn't it? Like the simple g prime. And now our task is to replace this a with what? Its actual expression. Its actual expression was what? hx, and hx is represented by what? 4x. So let's write it over here. Let's write. Let's make things a bit simpler, because it does seem a lot complex when a lot of mess is around. So a simpler way to approach this is, like, a simpler way to write this is, let's say, This was 4x plus 6 to the power 3 by 2. And we are considering like g of x as 2 of the equation, where we have g of a, which is, let's say, a to the power 3 by 2. That means where a equals to 4x plus 6. So that means we have to at first find, in order to find g prime of x, we have to find like g prime of a at first. So g prime of a means we have 3 by 2 a to the power half, isn't it? Now, if that's the case, substituting this a with the actual expression where a is represented as, let's say, h of x, and hx is itself 4x plus 6. Okay, so f prime of x equals to g prime of h of x. Now, when hx comes inside, we have to implement that h prime of x. But initially, we don't need to. Things becomes complex if we like initially say a is x, because when we don't consider a as x, that time it becomes like very easy for us to like implement this expression. But at the moment, when the inner function is a form of x, like there is an x, that means that inner function itself has to be differentiated. So that means whatever portion or whatever expression, whatever the number of expression we have, if there is a new x like included, we have to differentiate it. So here we are differentiating that. So that means g prime of hx is, let's say, 3 by 2, and a is represented as hx. So hx is what? H, like g prime of a or g prime of hx is what? 3 by 2, and simply representing a with hx gives us h of x to the power 1 by 2 into h prime of x is what? This one. So h prime of x we will be writing, but before that, now we are going to do that. 2 by 2 into h of x is what? We have to substitute this value. So 4x plus 6, 1 by 2 times h prime of x is, we have to find it. So h prime of x is equals to 4 times x to the power 0 plus 6 times 0 times x to the power minus 1. That gives us a value of 4, just 4. That means we have a 4 here. So simply this 2 and 4 gets cancelled out. We have a 2 here. So 2 3 is a 6. 6 times this half, we can simply write it as root. So 4x plus 6. So this is our final value for our f of x. So our f of x is, f prime of x is 6 root 4x plus 6. That's our differentiated value. Okay, using our chain rule. That was our first portion. Now we will be dealing with this expression. Let's go to a clear board. So our equation was x square multiplied with root over 4x plus 6 whole cube. So that means we have to find dy by dx, and we know we have this product rule. So product rule means this is considered as u, this whole is considered as v, and u, if u is x square and v is writing it in that terms of 4x plus 6 to the power 3 by 2. So u prime of u prime or du by dx is 2x, isn't it? Now, writing dv by dx, we found it previously, which is our fx, the previous page's fx, which was 2 times 3 was 6, 6 root over 4x plus 6, or write it as 6 plus 4x plus 6 whole to the power like half. So that's our dv by dx. Now simply we know dy by dx is what? Du by dx into v plus what? Plus u times dv by dx. So there is a Bangla term to say this, that like the first term is VK like VK UK differentiation. The next term is UK VK differentiation. That means leaving V, differentiating U, leaving U, differentiating V. So this is a like easier way to like remember in terms of phrase, because we people are like much more used to simple name rather than expressions and formulas. So it is easier to like remember that the first term is differentiating U leaving V, and the next term is differentiating V leaving U. Means leaving U or leaving V means we're in the first term we are leaving V. We are not differentiating V, so we are leaving behind V, and in the next term we are leaving U behind. Okay. Now just simply place the expression which we just found. So instead of du by dx, we will place this value, which is 2x, times the v, which is over here. So 4x plus 6 to the power 3 by 2. Addition. So this was one of the expression, and the next expression is u, which is x squared, multiply with this dv by dx, which is 6 times 4x plus 6 whole to the power 1 by 2. So this is our another expression. Simply breaking the bracket, we can also simplify them. Like we can take whichever is common from over here. So we have x common. Like let's simplify this to x. 4x plus 6 to the power 3 by 2 plus x squared times 6. Sorry, 6x squared. 6x squared. 4x plus 6 to the power 1 by 2. Now we can take things common from here, or we can simply leave them as it is. But taking things common looks things like easier. So 2x we can take common. In both the case we have 2x common from like over here, and over here we have 4x plus 6 common. But which one to take? Remember to take whichever power is the smallest. Here we have what? This power is 3 by 2. That means we have 1 plus half. And over here we have just simply half. That means which is much more smaller. Half is smaller than 1.5. So we would take 4x plus 6 half, and inside the bracket there will be left behind 4x plus 6 plus, over here will be like here it will be left with 3x. So 2x, 4x plus 6 half to the power half, and over here 4x plus 3x, which is 7x plus 6. That means we have an equation 2x, 4x plus, sorry, 7x plus 6, and 4x plus 6. Just writing that power of half as the root. So this is our final expression using the chain rule as well as the product rule. Chain rule was implemented over there inside the function, which has itself a function inside and the power outside. That was used to solve that chain rule. Like the chain rule was used to solve that part. I mean that v was differentiated using the chain rule, and the whole thing, this y as a whole, was differentiated using the product rule. Okay. Now coming to our so far last rule of today is our quotient rule. The quotient rule is like sort of similar to our product rule, but it's again a bit different, but still it works. It is when we have a fraction. So our 6th number rule is quotient rule. Now, quotient rule says if we have a function f of x, which is represented in fraction, so g of x over h of x. Okay, that means if another way of saying this is if we have a, okay, first let's define this. If we have a function f of x is equals to g of x by h of x, then f prime of x is represented as g prime of x multiplied with hx minus gx times h prime of x over hx whole square. In other words, if this function terms fx, gx, hx becomes difficult for you to understand, contemplate, then writing it in other way is y equals to u by v, if that's the expression. Then we would say dy by dx equals to du by dx multiply with v minus u times dv by dx divided by v square. If that makes sense. That means the first, like it is similar to the product rule, but again, like it's a bit different. The product rule at the numerator, it looks similar to the product rule, but again, here in the middle, it is a subtraction sign instead of the addition sign in the product rule. And we have to divide this whole with the v square. If we do an example, that would be easier for us. Let's say we have y equals to x squared plus 1 over x. Now, how do you then solve this? We can use that formula, this quotient rule. So dy by dx is equals to what? If you consider this as our u and this as our v, then du by dx is what? Du by dx is 2 times x. I mean, yeah, 2 times x to the power 1 plus 1 is the constant, so 1 becomes 0. So that means we are left with 2x just. And dv by dx is what? Since we have a x, differentiating x gives us what? 1 times x to the power 0. So that is equals to 1. So now placing them over here gives us du by dx. So du by dx is our 2x times we have v in this case is what? X. So x, let's write multiplication as dot. So v is here x minus our u, which is x squared plus 1, multiply it with dv by dx, which is 1, divided by x squared, v squared, which is in this case, v is x, so x squared. So that as a whole is our expression. So 2x squared is this part, the first part, du by dx into v, that part gives us the value of 2x squared. Second part gives us the value of x squared minus x squared minus 1, because when the bracket is broken, it is distributed on all the signs. So minus 1 over x squared. Simply like doing the addition and subtraction, simplifying the equation gives us x squared minus 1 over x squared. So that's our quotient rule. Okay, so that's how we do or deal with our quotient rule. So that was so far our last rule of today. Now let's do a couple of examples so that it becomes clear for us. Let's say we have a expression fx equals to x squared into sine x. See here we have a product of two different expressions. Over here we have sine like x squared, and there we have sine x. Two are both different expressions, but we cannot write them as a whole. Like whenever we can combine the x's together, that time it's fine. It is considered as a single function. But whenever the x cannot be combined, this x and this x, see, cannot be combined together. Like we cannot write them as a whole x. Like you cannot like simply do simplification and write x cube or like anything. We cannot write that. So in that moment, just be sure that there are two expressions, and over here, like you have to just see, are they multiplied? Then we have to use product rule. Are they like in fraction? Like if they were in x squared by x sine x, we do the same thing. Let's have a few examples. Fx is given as x squared into sine x. Then we have, let's say, another expression fx equals to x squared by sine x. Another, let's say, fx equals to x squared plus sine x. We'll be doing same sort of math with different like approach, and sine x by x squared. Okay. Now consider this and say which of them represents what. This is, we need to simply use what? Product rule, because they are product of each other. Over here, we just learned they are like fraction and the x cannot be combined with each other. That means what? this is going to follow one of the like other rule. This it represents the quotient rule. Quotient rule. Over here, this represents what? Two different expressions, but they are added with each other. So simply, this is the sum rule. Here, this also represents the quotient rule because they're in fraction and we can represent them as a whole. So this is also quotient rule. Okay. Now let's do the first one, the product rule one. Since here we have x squared plus sine x, so let's write it in terms of y, x squared sine x. You can interchange them. Okay, y with fx, fx out with y. But remember to write, if you are interchanging them, then just write simply fx equals to y. So that like the examiner knows the transition, that examiner is like, okay, the person who gave the exam knows the transition and knows the morality. So yeah, now y goes to x squared sine x. This should give us a value, like when we differentiate them, we know what the product rule is supposed to be: du by dx v plus du dv by dx. Okay. Now here, let's consider the first one as u, then the next one is considered as v. So du by dx in this case is going to be what? 2x. And dv by dx, we have learned it in the last lecture that sine x, when you differentiate them, gives us a value of what? Cos x. So simply placing them over here, du by dx is 2x into v. V is what? V is sine x, plus u is in this case what? X square, and our dv by dx is what? Cos x. Cos x. So we're getting the term that's 2x sine x plus x square cos x. Okay, this is the result for our first part. Now coming to the next part, I mean the next equation, we have x square over sine x. So this was done. So we are cutting it. We're doing it, the second one. Here we need to implement the quotient rule, so x square sine x. So here we would consider the above as a u and this as v. So du by dx is, as we have seen earlier, 2x. dv by dx is also, we have seen cos x. Now dy by dx is what? We should be getting u prime v. In the simplest term, I'm writing it, okay? We can also sometimes represent du by dx as prime. So here I'm writing u prime v plus v prime u for the simplicity, or you can just simply say u v prime divided by v square. For the simplicity, I'm writing this, okay? So u prime means du by dx, which is 2x into v sine x, plus our u is x square, and v, sorry, this is not plus, this is going to be minus. I'm really sorry for that. Don't copy this mistake. Remember, this is a minus sign. There is always a minus sign in the quotient rule. And u is x square, v is cos x divided by v square, which is our sine x whole square. Remember, when you implement sine x whole square, we can also write this as sine square x. Okay, this is the same thing. These are the identical thing. So our expression is this one. Okay, 2x sine x minus x square cos x divided by sine square x or sine x whole square. Okay. Now going to the third equation, we are going to solve the third equation as y equals to x square plus sine. That is very easy one. So dy by dx, simply implementing differentiation to each of the individual term. So this, let's say this is g of x and this is f of x, the h of x. We are going to simply find g prime of x and f h prime of x, and we are going to add them together. So the final result will be g prime of x plus h prime of x. In this case, this should be 2x plus sine of x is, like differentiation of sine x is what? Cos x. And the last one, this one, we will be using quotient rule. So y equals to sine x by cos x. I mean, sorry, sine x by x squared. And we have seen that, in this case, we'll be considering, like, we have to change the u and v because they're upside down. So this is no u, this is v. So du by dx is in this case cos x, and dv by dx is what? 2x. Now dy by dx is what? U prime v minus v prime u, or you can write simply u v prime. anything is suitable. Like you can place this v prime in front and u at the back. That's also correct. And finally v square, like divided by v square. So u prime is cos x. We can, like, as I've mentioned earlier, we can write du by dx as u prime as well, and dv by dx as v prime. So that's the shortcut of writing. So cos x times our v was what? V was x square minus u is given as sine x multiplied with what? 2x, which is our v prime, divided by v square. V square is x square whole square, because our v is x square. So our final result is x square cos x minus 2x sine x divided by x to the power 4. Okay, that's our final result. So I know from the last lecture you were unable to solve the equation, solve many of the equations which were given homework. But now, after implementing these formulas, I would urge you to solve the equation. At the same time, let me give a hint of certain type of equation. Let's say we have our expression sine 5x. Okay. If sine of 5x is given, then remember, as I've mentioned, if anything is outside the bracket, that's considered as another, like, one whole function. And if anything is inside the bracket, that's another function. So in this case, if this is fx, then remember, gx is over here is sine of something inside. Let's say g of a is sine a, and a in this case is 5x, or a is as hx. Okay, so that means g of hx here is what? Sine of some other function inside, and g of x is that sine of 5x. That means this inside, like whatever is inside the sine function, that itself is another function. So if you are going to find differentiation, how do we do it? Remember, f prime of x in that scenario is what? G prime of hx multiplied with what? H prime of x. So use that method to solve this expression. I'm not going to show this in this lecture video. I'm going to show this in the next lecture video. Okay, so try it by yourself. Inshallah, you'll be able to solve most of the equation. If you couldn't, then don't hesitate. Inshallah, we'll be solving them together in the next class. Okay, take care. Allah Hafiz. Assalamu alaikum.